the reality is that China is producing 90+% of drone components in the world. And it's not something that we can catch up to fast enough. And the China has really more than 100 times capacity if they really want to push things even faster. And this reality is problematic because it's not just quantities, but also the methods that we use are exposing us to asymmetry, not in capabilities, but really also economically. You can't, if you scale this asymmetry, you realize that we can go bankrupt on the real war with such an adversary.
Welcome to the autonomous age, where drones map our cities, robots save lives, and underwater vehicles scan the ocean floor. I'm Shai Senior, and this podcast is your front row seat to the real stories behind the machines shaping our future and the people behind them, from the engineers and researchers to the entrepreneurs and investors.
Okay, so I'm excited to be here for another episode in our podcast, The Autonomous. And today, I'm very happy to host Moshe Baum from Wild West Systems. Before you will introduce yourself and share about the company, I'm really happy to every time find about a new company. It's right that we're talking mostly with Israeli founders, but there are also Israeli founders that are living in the States for many years. And I think the journey that you've been through from my research is super interesting. And I'm excited about this episode. So let's begin and tell us a little bit about yourself.
Sure, I'm excited to be here. Brief history. Moshe Baum, originally from Israel. I started my career in defense. I was an officer in the IDF in a unit called Rapat, developing the Merkava tank along with the Namir APC, heavy armor personnel carrier. I was there from the very beginning of the program. I was responsible for a lot of systems in the vehicle, many of which are still deployed in the field to this day. This is really where I kind of grew up as an engineer and learned most of what I know as mechanical engineer. After the military, me and a few other friends from the military founded our first startup called Mobius. We developed blast mitigation technology, and the company does well and still exist and doing well in the defense space, and they later had a couple of spin-offs into other industries um, yeah, I moved later to the US, worked for some interesting companies like Tesla, Apple, Special Projects Group, and SpaceX. Yeah, and after observing the emergence of the asymmetry we see with what started in war in Ukraine and also later the war in Israel with the use of small drones, light UAVs, and a lot of people are kind of not really focused on that. Drones also played a role in October 7th. So in the beginning of the attack, drones were used to disable some of the systems along the border with Gaza, and that also enabled some of the invasion. So this new type of asymmetry really changes a lot in what we see on the battlefield, and this is something that's only going to accelerate. And that's kind of what triggered my renewed interest in defense, and well, I decided to start Wild West.
Wow, I have so many questions only on the intro, but I want to go back actually to your background. And Amer and the Merkava are actually the vehicles that our soldiers are using here in Israel for the past almost 3 years now. And even during those days, they're developing more add-ons and many different types of things in relation to drones to put on. But I feel that there is one specific thing about it. People sometimes imagine an APC in a big vehicle, so it has a lot of space on top of it, and then you can add different things on top, and people could sit on the outside. I remember from the gaming, we used to play Halo, and then you can put your person to sit on the tank from the outside, and that's how the troops are moving from one place to another, not wasting energy. So if you can say just a little bit about the mechanical engineering and the importance of the outer side of those vehicles, because I feel that for most people that are not mechanical engineers and specifically in APCs, it's an important point to know before we dive into the drones.
Yeah, I mean, obviously, and again, this is things are changing all the time in military technology, and one armored vehicle is not the same like the other. You can see the smaller aluminum-bodied armored personnel carrier, and that are only armored up to light munitions, and you have the heavy armored vehicles that can take more abuse and direct hits, and you have technologies like active armor and reactive armor that can negate attacks like RPGs and missiles. So these are technologies that never really stopped developing. The use and the amount of armor that is deployed over armored vehicles often depends on the level of risk and where they operated. Some of them also carry underbelly armor when they go into areas that are heavily mined and stuff like that. So every armored vehicle, sometimes it's suited with different type of armors depending on the mission. And, this is same like we see, in ancient times. There's always a race to add more armor, but at some point it starts becoming too heavy and it gets the agility. So you move to different methods and tactics on battlefield. And this has always been a debate whether do we really still need these heavy ground armored vehicles, or do we need to put focus on more agile or the Air Force and things like that. There's always been a debate. Even in my time, I remember that there's always been this budget fights over whether we should keep funding these heavy armored vehicles versus we should just put all the money in Air Force and stuff like that. And I mean, the reality is it's always a combination of capabilities and methods of how you deploy mass on the battlefield and how you inject forces into the battlefield and mobilize them in and out. Um, Armored vehicles are really, it's something that's built to allow to go deep into enemy territory and to protect the occupants inside. Definitely not something you sit outside. This is built for shielding the occupants inside as much as possible from threats, and there's also different level of armors depending on the location of the vehicle, strategically placed where the higher probability of hit. So there's a lot of technology and a lot of methodological thinking of how you design armored vehicle, how you deploy, how you place the armors around it, and what types of armors are used where. And again, this is something that is constantly changing. It's constantly improving, and it will change also as the threats change. The technology to face this threat change as well.
You mentioned Tesla, so I think most people would imagine tanks in 2026 to look more like Tesla style. And pictures from Russia and Ukraine, every time surprise me how they went backwards, if I can say. Like, it looks like vehicles from 150 years ago with spikes on top of them and a net. And I think that it's very much related to the threats that were born and raised very quickly into the field, and then the troops on ground had to make some changes, not too much time of engineering, and send it out to the field.
Yeah. So first of all, I always tell people that look in the current theater in Ukraine, Russia. These are should take with a grain of salt any lesson from there, because these are really two dated armies that basically improvising with UAVs. But what we see there is not even the tip of the iceberg of what we're gonna see in the very near future with drone warfare. Some lessons from there are relevant in terms of various simple, quick and dirty methods to counter drones that can. The type of drone warfare that goes there, really very small charges that are much more effective when they drop directly in full contact with the vehicle. So they have all these nets and cages to both make them less identifiable for various image recognition algorithms, but also if a drone goes nearby, it has a little bit of a gap, so it doesn't create enough of an impact on the people inside. But again, these are all very crude methods, and I think things are going to evolve way past what we see there. Most of the technologies we see in Ukraine, Russia is primarily human piloted. This hasn't yet crossed into fully autonomous systems in masses, and this is really what comes in the very near future. If you imagine like a little bit more sophisticated army, and if you can imagine where things might go, you can see the 10,000 drones light shows from China, and you can imagine that this is not just for entertainment. You can imagine where the future is heading when this is the type of masses, and when these become autonomous and weaponized, and that's the real emerging threat that we see.
So if I'm looking a little bit into your background and we talk about Tesla, Tesla and SpaceX, I believe or guess, but we'll get the answer from you, are quite similar in the way the organization is built. Apple is probably different. How was that adaptation coming from the Israeli military and then working in these organizations?
Yeah, I mean, I think there are a few parallel, very similar themes across, and there are several very big differences. I think the the common thread across all of this that goes also back to my military time is the deep emphasis on first principles and really fundamentally analyzing problems, breaking down problems to fundamental pieces, and really solving them from first principles and
Sounds like
applying.
it's breaking them to screws.
Yeah, I mean, I was lucky enough to, the unit that I served in the IDF was really taking engineering very seriously and was really innovating in the space of armored vehicles and tanks. And that's why, IDF equipment is much more capable than uh, other tanks and armored vehicles you see around the world. And I think the same approach both to first principles and to rapid iteration is something that um, I've seen throughout my career in all the companies that I was lucky enough to work for. I think the main differences is really the approach to the market. And again, there's no right or wrong. I have my own opinion, but typically in Tesla and SpaceX, there is a rapid iteration going on, but usually there is a sense of urgency to get the product out to the user's hands as quick as possible. And function, I think, comes before form. And in Apple case, it's really they would rather sit on a product for years. There is a sense of urgency inside to develop a product, but there's no sense of urgency to release a product unless it feels absolutely perfect. And in my opinion, again, Apple is all these brands are very successful. Apple has established a certain level of quality facing the users that they don't want to risk dropping any below a certain perception of quality, and they would rather develop a product for 10 years and still not release it if they don't feel it's good enough. This is something works for Apple, but I think for startups or any other company, I think the approach of SpaceX and Tesla works better because you do want to put things in the field and keep improving and iterating while it's all you already learned from users. And I think this also kind of mirrors the way that we designed the IDF when designing tanks and our vehicles. We would very quickly put something even like basically a prototype in the hands of soldiers on the field to start getting feedback even before the product is really fully complete. Back in the day, we used to call it telescopic development. Different places coin their different terms, and the idea of the is called telescopic development because you start something and immediately you get the next iteration. Many times would bring back all the prototypes and retrofit them to improve to match the latest designs. But this is basically a much better way to both get user feedback and keep improving the product with real lessons from the fields. I support, especially for startups that are bringing new products to market. I think the approach of Tesla and SpaceX works better if you can get the products out there and start getting real feedback.
Um, so you had access actually the biggest tech companies in the US and if to say also in the world. Why did you live it? And that's, of course, leading us to learning more about what is Wild West about, and what did you see and feel after all those events that you mentioned before taking place around the world that made you leave and start working on your own thing?
It's sometimes you have an idea that kind of grows inside, and you really feel passionate that you have to do something. You have a certain view on how things need to get done, and you have a clear path in your mind, some clarity in how to get it done and how it should be done. Do you realize that the best way to do it is do it yourself? And this is kind of the way that at first I started tinkering with some ideas while I was watching what happened in Ukraine and how US is spending $2 million worth of cruise missile on every $2,000 worth of footy drone. And you can see that if you spend a little bit of time thinking through it, you realize this method really doesn't scale and this current reality doesn't scale. Basically, we're in a situation that current industrial base in the US, the reality is that China is producing 90+% of drone components in the world. And it's not something that we can catch up to fast enough. And China has really more than 100 times capacity if they really want to push things even faster. And this reality is problematic because and it's not just quantities, but also the methods that we use are exposing us to asymmetry, not in capabilities, but really also economically. You can't, if you scale this asymmetry, you realize that we can go bankrupt on the real war with such an adversary if we don't change how things work and how things scale. So I basically, the thought process is how do we change the equation such that we can defend against such type of new threats in a way that is cheaper than the threat itself, and also to make it such that that every asset we have is reusable. And that's what basically prompted what we're doing in Wild West. We're developing weapon systems that are specifically designed to arm UAVs, to make them capable of reusability, to make it capable of engaging one-to-many instead of just one-to-one, basically going past the kamikaze type interceptions that go to basically weaponized systems that can engage one-to-many and keep being reusable. So basically being a force multiplier instead of just wasting assets as kamikaze.
So kamikaze as itself, it's a hard operation, and you need, in order to scale, one very experienced operator in order to operate one kamikaze drone.
Correct.
You're talking about scaling it to swarms.
Correct. And but part of the equation is not just the special weapon systems we design, but also the autonomy stack, the edge AI compute that sits that comes along with the weapon systems and basically allows both guiding the drones and the weapons to where they need to go, but also taking into account the new reality where you cannot really rely in the modern battlefield on remote communications. And this, again, some of the lessons we do see from Ukraine, jamming or GPF spoofing are common. And you can't just rely on a human pilot flying a drone one-to-one. You can't rely on one human pilot per one system. That doesn't scale. And you also can't rely because you can expect that signals will be jammed, GPF will be spoofed, and you won't be able to keep control on the drones. So where the future is leading is every system to deploy need to be capable of maneuvering and completing a mission without a human in the loop, or at least with a partial human in the loop. So if you lose communications, the system can still go on and complete its mission. So that's where everything is heading, and the reality that you see today in Ukraine of one pilot per one system, this is something that will not be. It's not something that will be a reality. I think even 5 years from now, this is going to be an obsolete method. Yeah,
Was it like one thing that you've seen that have changed drastically in the technology that you said, okay, now it's the right moment, that's the right timing? Or because, I'm listening to Palmer Luckey from Anduril and Ethan Thornton from Mach, and they say it's actually the timing and the situation worldwide taking place that we've realized. I'm taking Ethan Thornton as an example. So if he will continue studying, when he will finish studying, the US will
Yeah,
be
I think. Uh,
already.
yeah, I mean, I think everybody kind of it's kind of a human nature that you don't believe a problem is real until you see it. And I think it's not that people didn't recognize the threat is coming. You know, the DJI type small cheap drones have been around in the last 15 years. I think everybody understood this is a potential vehicle for weaponizing. You can also see that there are like public available data of exercises, military exercises as far back as 2018, 2019, that were already practicing what would it look like if a swarm of armed drones are attacking a base. And I think a lot of people realized early on it will become a problem, but until it becomes real, nobody really want felt the urgency to do anything about it. It wasn't taken in the same sense of urgency until the war in Ukraine showed the actual practicality of taking very cheap systems that you can literally build in your garage and very cheaply and easily weaponize them. So I think the war in Ukraine really accelerated the realization and a little bit of panic across the West. And this is really what kind of pushed a lot of the new technologies that we see today.
Yeah. And to be honest, I feel that there is panic, but not yet enough understanding of how simple it is to buy a drone or to build a drone in your own garage and put, even a Molotov bottle on top of it. You said before that Russia and Ukraine are not example of what exists, but Amazon, is a very easy platform to deliver things. YouTube is a great platform to learn how to build drones. And I feel that there was a little bit of conversation like last month that they talked about Iran maybe trying to attack the Oscar gala in Los Angeles, and everybody in California was scared. But then what were actually the tools to deal with such a swarm coming over, and who is actually responsible for that? Those are the questions that I had in my head.
Yeah, and unfortunately, that's still something that I don't think there is good policy or set of tools yet. I mean, the reality is that even law enforcement today is not authorized to shoot down kinetically a drone, unless maybe just very sensitive military locations, but generally around civilian installations and infrastructure that is much more vulnerable. For example, law enforcement, as we speak, do not have any authorization to shoot down kinetically drone and not identified drone. And this is a problem that, again, unfortunately, as I mentioned, this is kind of human nature. You prefer to not address a problem until it's right in your face. And I would imagine that we'll see a shift in policy once this problem materializes in some way inland. We already saw along the border there are cartel drones that are going over the border on a daily basis, and there are some incidents that reported that were shut down. But I think the more things like this happen, the more policy will have to shift to be more flexible in terms of what law enforcement can do to counter such threats.
So I want to speak a little bit about flying and building because it's two different things. We mentioned kamikaze drone that needs a very experienced and high quality of an operator. And then you as an engineer are used to develop things in labs. How does it actually look like to come up with that thing out to the field? You've been doing it with an ML, you sent it to the end user, they test it, they come back with feedback. How does it look today that you want to develop a swarm? Where do you
You
check?
obviously test a lot before you give it to the end user. Even when we developed a vehicle, a lot of the systems that I was responsible for were blast mitigation systems. So we obviously blew up prototype vehicles to see how they perform under real world scenarios. And same things here. We have a range here in Texas that we do live testing of our systems. A lot of the development today when it comes to the AI compute, this is something that actually you can do a lot of the development in simulation environment. And again, the whole AI portion of the equation is something that changed very significantly in the last 2 years, I would say. You can do today with two software engineers with the aid of AI tools, probably within few weeks, something that 5 years ago would take a team of 20 engineers and will take you a year. And a lot of the development we do, we can test in simulation environment before we even test anything on the field. So that accelerates a lot of the development, a lot of the testing. And by the time you go and test something in the field, it's already, you don't start from scratch. You already have enough information that you tested in simulation, and is really much more mature than a prototype you just start testing.
So the actually every 3 months you mentioned the amount of people on a team that is needed, but as I see it, it's also scaling the capabilities of vehicles that would cost much more money or would have to wait much more. And now with the capabilities of auto learning, they're actually becoming more dangerous, but also easier to build, if I get you right. And
Yeah, and it's not just that, it becomes a necessity because, as I mentioned earlier, the reality of the modern battlefield is that in contested environments, you should expect jamming will be used and GPS spoofing will be used, and you won't be able to rely on any remote control or remote piloting. So systems that are developed for a modern battlefield need to be able to autonomously complete a mission or being able to operate it for long windows of time when there is no human capable of interacting with it. And the only way to do it is to have some onboard AI compute module that can take its own decisions and continue its flight plan without someone telling it what to do, where to go, and so on.
where do you think the balance lays today between human operated, autonomous, or partly autonomous vehicles?
So I think, and I don't. A lot of people recognize it, but I think most people still don't really appreciate the massive transformation that is happening today. And in my opinion, this transformation, it can only be compared to the period where humans moved from horsebacks, bows and arrows, to using gunpowder and mechanized vehicles, airplanes, and tanks. It's this level of change that we see happening in a very short period. And I think the what we are going to see in the next decade, potentially less, we're going to see more and more robots, whether it's drones, ground robots, in air and sea, and on the ground and in space. We'll see robotic systems replacing more and more humans on the battlefield, deploying robots some more on the front lines, and humans go back further back. And I think that's gonna be something that will become a very obvious reality in less than a decade. And I think this is a transformation we see now, and I think it's only going to accelerate.
So I get it about the balance between human and autonomy, and then swarms. What's actually real about it? Because there are
Yeah.
so many
So
videos on social media that
yeah.
people cannot
Yeah.
really understand what's real or not.
I mean, you see a lot of Hollywood style posts from China with the robot dogs and humanoids and this and that. We're not there yet. I think we're definitely heading there, both directionally. They're not hiding their intentions. We all grew up watching Terminator, and so it's not hard to imagine that humanoids will be used more than just to folding laundry in a hotel. So everybody obviously understand that this is a part of the bigger picture. I think this, the humanoids part and is a bit further away. Robot dogs, this is a bit closer, but I think it all comes down to how economically things scale. And I think drones are already here. I think drones in masses is gonna be something that we'll see much closer than anything else, just because it's very cheap to make. It's very low barrier technically to achieve that. Again, it doesn't take much to move from 10,000 drones on a light show that are coordinated in these beautiful patterns, and imagine what it looks like when you assign each one of these 10,000 drones a specified, even a predetermined flight plan. It doesn't even have to be autonomous. It can be like a Roomba. You basically give it just a route, go, and tag it. If you have a system that is 99% capable of taking them down, it's enough for 1% of them to make it to the destination and cause massive amount of damage, and the damage will be more expensive than the entire worth of this entire swarm. And that's the problem with the symmetry, and that's why we're focusing very much attention on the group 1 and group 2, the small UAVs, because these are the cheapest, these are the easiest to produce at scale, and they create the most damage in terms of asymmetry. But when you start talking on the group 3 and 4 and the larger, bigger platforms, then you start talking about platforms that cost a lot of money, cost 100 or 200 grand at least for a platform. And when you talk about this kind of costs, the countermeasures also are almost the same as the threat itself. When you talk about small group 1, group 2, they can be anything from few $100 to a couple of $1,000. But the damage they can create, just like we see in the spiderweb, if I recall the name of the Ukrainian thing, they can cause damage in the billions. And if you talk about even systems like the Epirus or any of even the laser systems that are good to an extent until they're not. And the problem is that when you have a very expensive ground-based system, it can be very easily be overwhelmed. Let's take, for example, the laser system. Very cool idea, but they all cost very, very much. And if you have a $10 million worth of system um, that sits and can shoot one at a time, you can do the math, very quickly realize that to overwhelm the system, you need still a fraction of the cost of the entire system, and for just one or two drones to go through and then take the system out and move on. So, and that's the problem of asymmetry. So drones are already here. Drones are all the technology pieces are here, and I think we haven't yet seen it deployed in the field in that way. But I think that we are going to see it in the very near future.
And wow, it's actually an interesting perspective that you're giving here, because if I understand it right, you're talking about a swarm that meets a swarm outside of where your assets are located, and then you will stop them there. So they would get assigned targets from a person, or they know to look for targets in the air.
Yeah, and there are different technologies to how you classify and how you identify targets, but generally speaking, what we believe will be the most effective way to counter swarms will be, again, there's always a layered way to approach threats. The most effective way to approach a threat is obviously to extend the engagement envelope as far as you can and meet the threat before it comes to you. Um, and that's the reason why we're focusing on arming light drones, so we can basically have dogfight, so to speak, and be able to engage such threats and take them down autonomously far before they are within a target that they try to attack. I think there's going to be a room for all other systems, and there's going to be a room for lasers. There's might be room for the hyper microwaves and things like that. But when you talk about really large scale swarms, the approach that we believe is the most effective to engage the threats as far as you can before it arrives is doing it in the air with matching capabilities, but being more capable and mitigate the threats as far as you can.
So the idea is that there are kind of nests that those swarms go out of. Like, where do you keep the vehicles or the system?
Yeah, the way we look at it is something can be either be placed in basically, like as you said, like a nest, can be deployed from other mothership kind of thing. You saw can be deployed from other vehicles. That's the thing. If you focus, the reason we're focusing on the lighter, smallest platform is it allows the maximum flexibility and the lowest cost in terms of scale. So if you can arm the lowest cost platforms, and you can keep reusing them, you can also scale them, and you can also decide how and when you want to deploy them. And the smallest, the lightest it is, the easier it is to deploy it however you want. And you could put a bunch of these dormant. You can deploy them from the air, from a larger vehicle. You can, or from the ground, from other vehicles. You can carry with you in a backpack. That the whole point is that if you make these smaller platforms more capable, then you're basically keeping all the flexibility to deploy however and wherever you want.
Are you guys now in a stage of integrations? Like, I'm sure that you're located in Texas, of course. I can say that from the name, Wild West. Did different people with different ideas come up to you and offer some integrations with your platform?
We're working with several integration partners, and yeah, we've already been doing several live demonstrations of our technology. We're also handing some of the systems to the army for testing.
What's so special about Texas in relation to drones?
Yeah, I mean, obviously, when you test kinetic systems, you can do a little bit more in Texas than you can do in California. Obviously, everything under ATF rules, FAA rules, and so on. But there is a little bit more flexibility to test kinetic stuff in Texas than in other places.
So I can just imagine it's like a basketball field that you say, I'm going to rent it for 2 hours and explode some stuff here. That's
Yeah,
my experience.
we're using a range, a large range, about 40 minutes from our office, that is used by a lot of other DoD type companies and customers. It's very common. There are a lot of test ranges here, and yeah, it's pretty common to we blow up stuff, they blow up stuff, and everybody are testing different technologies in the same range. So it's pretty cool to meet other startups, different startups trying different things. So it's very cool to see the whole ecosystem kind of growing around here.
You haven't yet invited me to Texas, but I'm already inviting myself. So next time that I'm in the US, I'll come by and I would like to also test some things in your range.
Mostly welcome. There's always something to blow up in the range.
So Moshe, for people that are out of that space of unmanned vehicles or let's be more specific, swarms and lethal drones, what is something that is misunderstood about robotics in general in your perspective, or specifically about drones and swarms?
I mean, I think several things. First of all, you see, it's like people saw the Boston Dynamics videos from like a decade ago, see a robot doing flip-flops and flops in the air and jumping and dancing and things like this. A lot of the stuff you see online are very curated, very handcrafted demos that are not necessarily something that you can just easily do the same thing in different environment, or generically apply to every single scenario. It does take a lot of training and a lot of engineering to make a platform capable and accurate and repeatable. Also, when you see a drone carrying an explosive or stuff like that, you always imagine that these are platforms still very limited in terms of flight time and range. Having, one demo of one thing, doing one thing, you always need to think about how it scales in capability, in range, and in costs. Every time you see a company demonstrating something, ask yourself if this is something that is A, does it scale in how quickly you can produce such a thing, or how cheap is it to produce? B, how repeatable it is? In what environment can you really replicate these capabilities? A lot of times you see one demo and you think, oh, capability achieved. Deploying it's not as easy. You see a lot of companies trying to shoot a drone from the ground with a machine gun that they tell you they can just find them and hit them. It's very easy when they fly in 5 miles per hour. It's not as easy when they fly 50 miles per hour or 100 miles per hour. And when it's very small and much farther away. So take with a grain of salt any demo that you see online. Consider what it costs to and what it takes to make one of these demos work, and whether it's something that can really be scalable, because the whole point in about drones is not just the capability of one thing, it's the capability to scale the numbers. And that's why, okay, so let's say, for example, something that needs to operate at night. Okay, so you need thermals, you need IR, you need different sensors. These sensors sometimes can cost in the tens of thousands of dollars if you want. And with good resolution, with good range, thermal or IR. Okay, so you can do one of them. How many can you really deploy like this? Are you going to spend now a 30 grand camera for every single drone they're going to use once? So that's the real problem when you see a lot of the demos and things. You see one capability, but you need to put in the context of scale. Scale is really the basic of every system in this new era of weapons.
Yeah, you bring up these points, and I'm thinking about supply chain. We just saw it in the Hormuz Straits. You're right. It's not IR cameras or engines. It's different types of compounds and materials that are mostly extracted from that area of the world. But then we can see how much it influences the economy in other countries.
And
What's
to
your
that
thought?
point,
Yeah.
just to that point, I mean, it's still a difficult problem to build drones with non-Chinese components. I mean, it's much more expensive to source motors or batteries or anything that are not Chinese made. And, there's still a lot of catch up to do in terms of Western industries to be able to have alternatives that do not use Chinese components. And that's a big problem. Unfortunately, it's still a lot to be done.
I've been a month and a half in the US before coming back to Israel now, and I feel that there are a lot of people there that are making sure this supply chain will exist and it will be a US made drones and systems, from the engines to the batteries to the bodies
But,
themselves. And they're talking about the new drones to be on the shelf for the kids next Christmas. But it also reflects on what will change and influence the defense industry. A lot of people and engineers like you that were more focused on companies, you mentioned California, and they were based on SaaS platforms and products that are for consumer needs, suddenly realize that actually it's time and they're required in the defense and homeland security industries if they don't want their families to deal with threats that exist out
I
there.
think it's slowly changed. The attitude is changing. I think Andrew kind of changed a little bit this attitude, and Andrew were really one of the first, I think, in Silicon Valley to really change the perception and start, putting emphasis on defense and breaking the mold in terms of the common thread in Silicon Valley that they don't, most companies didn't want to work with defense. So kudos to Andrew for changing that perception. And I think a lot of more companies now are starting to realize that you can't be too naive about the world we're living in. And I think that was one of the positive changes that we see in the US.
Thank you, Moshe, for all those answers, and it's super exciting the way that your company will go forward to. How swarms will take place in other places more than light shows across the world, and if you listening to us like this episode with Moshe, you have any additional questions or you'd like me to speak about any other topic in our next episodes. So first of all, leave a comment, and after that, share it with any friend or colleague that you think might be interested in our podcast and this specific episode. Thank you very much.
Thank you. Thanks for having me. Thank you.